So section 9 deals with percents, and we've kind of been leading up to percents in the last couple of sections. If you think about it, we started with section 7 with proportions, and then section 8 we went to similar figures. That all kind of leads up to percents. Percents also use proportions. If you take a look at this problem here that's listed in blue, it says some recommended daily intakes of vitamins are shown. So we have this like bottle of vitamins here or something. Carrie consumed 10 milligrams of niacin a day, or today. Her brother consumed 11 milligrams of niacin. Who consumed the greater percent of the recommended intake? Well, first of all, who consumed more? The brother did, by 1 milligram, okay? But the question says, who consumed the greater percent of their recommended intake? So this question right here gets at the whole idea of percent that we're talking about in this section. If I'm looking for a percent, I gotta take the amount that I got divided by the amount that is recommended, or the amount that I should have gotten, and that will give me a percent, okay? So for the vitamins, we have niacin sitting here, and then they've divided out into males and females. Usually with medications you go by weight, but that's okay. So Carrie, consumed 10 milligrams of niacin. How many milligrams of niacin was she supposed to consume? 14 milligrams. So what percentage of her recommended daily allowance did she consume? Well, we take what she did do, which was 10, so Carrie consumed 10, but she was supposed to consume 14. And we just divide that out. When we divide that out, we get a decimal. What decimal do we get? 0.714. Okay, so 0.714. As a percent, you would multiply that times 100, which basically means move the decimal over 2 places, and you have 71.4%. Have you guys learned that before? Yeah. Okay, so now the same idea for her brother. Her brother, who apparently has no name, so brother, how much did he consume? 11 milligrams. How much was he supposed to consume? 16 milligrams. And now we divide that out to get the percentage. What is the decimal of 11 sixteenths? So 0.68 exactly? Okay. So if we make that a percent, we move the decimal over 2 places, 68.7%. So to answer the question now, who consumed the greater percent of the recommended ratio or intake? Carrie did, because she consumed 71.4%. Okay? So the reason that we use percents is because it kind of equalizes everything. For the girls and boys, they consume a different amount. But when we start talking about percent, then that different amount kind of goes away. Now we're just talking about how much did you take in compared to how much you were supposed to take in. And this relates to like quizzes and tests and stuff like that too. If I give you guys a test and you get a test back, and on the test, by the way, your test coming up is going to be out of 70 points, and you get a 52 out of 70, and you want to know what grade that is, just divide them and find the decimal. Then move the decimal over 2 places. What would this percentage be? 74.2%. Actually, when you divide that, you get 0.742, but then you move the decimal over 2 places, and now you have your percentage. Okay? So that would be like a C, right? Would you be okay with that grade? Some people would. Some people would not. Okay? Some people would be excited to see that grade. Some people would be very disappointed to see that grade. So it just depends on who you are and what your goals are in life. But a 74.2 is a C regardless. All right, we have some vocabulary here. First of all, percent. What is a percent? Basically, for a percent, it's how many do you have out of 100? How many out of 100 do you have? That is your percent. So if I gave you a test that was worth 100 points and you got 72 points, then you got 72% on that test. If I gave you a test and there was only 70 points and you got 56 points out of 70, Then you would divide to find your percent, and that would tell you how many out of 100, if there were 100, how many out of 100 did you actually get, okay? That's what a percent is. There's algebra that goes on here. The algebra is A divided by B equals P over 100. So A is just a number. How many did you get? B is how many were you supposed to get, equals P, the percentage that you got out of 100. That's the percent proportion sitting right there. The model for this, if you want to try to picture this graphically, if I have part of a base, so this is the part here, and this is the base. So I have a test that is worth 50 points, let's say. And on that test, I got 25 points. So they're saying the base is 50 then, and the part that I got was 25. 25 out of 50, so 25 over 50. The percent then ranges from 0 to 100% for 0 points all the way to 50 points. Okay? So here I am at 25 parts out of 50 total. What percent is that? So that's 25 parts out of 50 total equals what percent is that out of 100%? That's what that's saying visually, okay? The way to remember this easily, especially in Algebra 1, if I'm giving you problems like what percent is 25 out of 72 or something like that. Those words is and of appeared. The word percent appeared in that statement, okay? So the way to remember percent problems is over of equals percent over 100. Has anybody seen that before or heard that before? Is over of equals percent over 100? Okay. So for example, what percent of 50 is 25? So the word is tells me where that number goes. The word of tells me where that number goes. And then it says what percent. So that means I'm looking for that right there. That's the one I don't know. The 100 is always going to be there. So I put my proportion down, and then I say, okay, is right here is 25. So I put that 25 there. What percent of 50? So the of goes here, so 50 goes there. And then it says what percent? Well, that's the part I don't know, so I'll put my x there, and then my 100 goes there. By the way, that's 100% sitting there. This is x percent sitting here, okay? So I'll put x percent here and 100% here. This is like a fancy one. Percent divided by percent is what? It's 1. Percent divided by percent. Anything divided by itself is 1, okay? So I kind of have a fancy one of percent symbols sitting there. So now all you got to do is cross multiply. We have, or you don't even have to cross multiply in this case, right? Because the x is on top. So we could just multiply both sides times 100. And that's exactly what we were just doing before. We took the two numbers, we took the score on the test or whatever it was and divided them, and then we wound up multiplying times 100. Well, that's exactly what we're doing here. We take the two numbers and divide them and we get some sort of decimal, and then we multiply times 100. We move the decimal over 2 places to the right. That is exactly the same thing. So 25 divided by 50, that's 1/2 or 0.5. We get x equals 50%. So that's going to be the key, remembering the is over of equals percent over 100 on these basic problems. They will guide you onto where to put those numbers. All right, what percent of 56 is 42? So think back to the is over of equals percent over 100. We're going to set up the proportion. And what do I put in this spot right here? That's my is, and it says is 42, so I'm putting my 42 right there. What do I put in this spot? It says of 56, so that's of right there, so I put the 56 there. 100 automatically goes here, so that means that I'm looking for what percent. So that's why the x goes in the percent spot. To do this problem easily, we can just cross multiply, or we can multiply both sides by 100. And then what do we get? 75% equals x. So 42 divided by 56 is 0.75. As a percent, that's 75%. 75% of 56 is 42. All right, try the next one. What percent of 90 is 54? So what do I put? Over 90 equals x over 100, and then we'd multiply both sides by 100. And what do we get for our answer? X equals 60%. There you go. So not too bad, right? As long as you remember the is over of equals percent over 100. That'll help guide you on these types of problems. All right, let's take the algebraic percent proportion. The percent proportion was what we were just working with. A over B equals percent over 100. Right here. And solve for A. If I want to solve for A, what do I do? Multiply both sides by B. And when I do, I get A equals B times that P percent. What you've done now is created what's called the percent equation, and it can also be used to solve problems rather than like setting up the proportion every time and then having to cross multiply. You can work with this percent equation instead. So let's use that percent equation now. What percent of 40 is 2.5? If I have A equals B times P percent, yeah, so we're going to have the 2.5 equals 40 times P. And then to get the percent, we would do what? Divide both sides by 40. And 2.5 divided by 40, but I want that as a percent, so we're going to 6.25%. What winds up happening is you wind up doing the proportion anyway. It just doesn't look like you did. If we would have written is over of equals percent over 100, then we would have the is 2.5 over 40, x over 100. So then we multiplied 2.5 times 100 and divided by 40, and we wound up with exactly the same answer. So the book tries to show you this equation. You don't really need to use it. You can use the percent proportion the whole time. So let's go ahead and move on using the percent proportion. What percent of 84 is 63? Again, that's going to be an is over of type problem. The 100 goes here. It says what percent, so that's that. So it's going to be 63 over 84. What do we get? What is it? 75%. Exactly? Yeah. Okay, go ahead and do the other two. Actually, go ahead and do all three of those. Set up the proportion for the first one for me. Good? Okay, so we get x equals 85? Okay, 85%. And set up this one. 63 over 90 is over of equals x over 100. X equals 70%. Okay, so far all of these problems have been exactly the same. We're getting an is and we're getting an of, and we're looking for the percent. How about this one? You took the Chapter 1 test and you got 53 out of 64 points. What percent are we talking about? What do we do? 53 over 64 equals x over 100. It's basically the exact same problem again. Really? How did that happen? That's really, really bizarre. Okay, well, let's do 46 then, I guess. 46 out of 64. Or is it 46 out of...
It's 46 out of 53.
Okay. I don't have the first clue how that happened. 46 out of 53. All right, so what do we get? X equals 86.7%. It's like a ghost came in and moved numbers around on me or something. They all come from the same file, so I don't know how that happened. Okay, so 86.7%. A lot of you would probably be pretty happy with that score, right? Yeah. All right. Moving on. Using the percent equation is usually better when you're dealing with a percent off, but you can still use the percent proportion. They are the same exact thing. So whichever one you feel more comfortable with. Personally, for me, I feel more comfortable with the percent proportion, so that's the one I typically use, okay? If you're dealing with percent off, like when you're shopping in a store, a lot of times the store will say, hey, this shirt is 20% off or something. Well, great, but how much is it going to cost? You can figure that out yourself fairly easily, actually, using the percent proportion. So you want to buy a shirt, it's normally $38.50, but it's marked 30% off, so what's the price of this shirt? So they're telling you it's 30% off, right? So there's two ways to do this problem. I'll do the way that most people do these problems, and then I'll show you the faster way. So the shirt you want to buy is normally $38.50. It's marked 30% off. What's the sale price of this shirt? So notice that we have is normally $38.50, right? But it's marked 30% off. So what is the sale price of the shirt? The question is, we have what is the sale price of the shirt here also. So we've used is twice. If I'm sticking with the is over of equals percent over 100, then a problem like this is going to screw me up. So I got to really think here. I'm going to set up the proportion. I'm going to have 100 sitting here. They give me a percent, 30. But which number goes where? So if you think about this, 100% is the whole thing, right? 30% is the smaller part. If I have a shirt that's on sale, will the sale price be smaller than or greater than the original price? It's going to be smaller. So remember, if we have the smaller thing on top and we're dealing with a proportion, then the smaller thing needs to be on top over here as well. The smaller thing in this case is going to be the sale price. So that's my X, and then my $38.50 goes on the bottom. But it's 30% off. So if I do this proportion here, I solve for X. By the way, I'd be cross-multiplying, or I'd just be multiplying both sides by the $38.50. That's going to give me X equals some number. $11.55. What did I find? Is that the sale price? That's how much off it is, okay? Because I found 30% off. So what I found was how much off it is. So how much will I have to pay? How did you do that? So you took the original price and you subtracted how much the sale price took off, okay? And you get $20.95, okay? $26.95 would be the sale price. So that's how you're going to have to do that problem. You find how much off you get and then subtract the two numbers. If you do that the long way. The short way is to do this. If it's 30% off, that's how much I don't have to pay, is 30% of the price. So how much percent do I have to pay if I don't have to pay 30%? I have to pay 70%, okay? So I can do exactly the same problem, but instead of a 30 here, I can find out how much I do have to pay by putting a 70 there. So I'm going to do that. X over 38.50 equals 70% that I do have to pay over 100. And now I multiply both sides by 3850, and what do I get? So 70 divided by 100 times 3850. $26.95. Get the exact same answer without having to do a subtraction problem after that. Okay? The other thing I want to point out is, what is 30 divided by 100? It's 0.3. What is 70 divided by 100? It's 0.7. So you're just turning the decimal, or the percentage, into a decimal. If I turn the percentage into a decimal, and then I multiply times the original price, I get the sale price. Okay? So if I'm 70% of the price, because I'm 30% off the price, then I can just go 0.7 times the original price. Try that one in your calculator. Just do 0.7 times 3850. Get the exact same answer. Okay? So that's just manipulating the numbers around and understanding what 70 divided by 100 means. It just means you're taking the decimal version of the percent. All right, next problem. There's a saying that as soon as you buy a new car, as soon as you drive it off the lot, it's worth less money. Have you heard somebody say that before? Really? Well, actually, this saying is true. As soon as you buy a brand new car for 50 grand or whatever it is, as soon as you sign the paper that says it's now yours and you turn the car on and you drive it out of their lot, it's now worth thousands of dollars less. It's like you just paid thousands of dollars to drive that car about 50 feet. And then after that, it depreciates more slowly. But right away, you lose thousands of dollars, which is why I'll never buy a new car. Anyway, the saying is true. Imagine you buy a new car for $34,000. Then it says exactly 1 minute after you drive it off the dealership lot, it's only worth approximately 91% of what you paid for it. And that is the actual number. The price of your car that you just bought is now worth 91% of what you just paid for it. So like if you drove it one block and stopped and sold it to somebody else, they would only have to pay about 91% of what you paid for it. So the question is, how much money is the car worth after 1 minute of you owning it? Well, we can set up a proportion here. What do you want to put on the top left side? We know there's going to be 100 here. X? Is that what you said? Yeah? Okay. Because that's going to be the new price, right? That's our resulting price. And the original price goes on the bottom, $34,000. Pretty nice car probably for $34,000. Maybe it's a truck, I don't know. It's only worth 91%, so I put that 91% because it's not a sale price. It's not like I lost 91%. It is worth 91%. So that would be 0.91 right there, and then I multiply it times $34,000. What do we get? Sorry, what is it? So 3077. No. Yeah, 30,940. I don't know what you did, but you entered something wrong. This is $30,940. So just by me buying that car, so whatever you did, I don't know, but do 0.91, because 91 divided by 100 is 0.91, and then times by 34,000, you should get this answer. Just by driving that car off the lot, brand new car, you spent over $3,000. It's money that you'll never get back. So like my truck, dying badly. I'm even wondering if I'm going to make it home every day when I drive home. Not going to buy a new car because I know that that's a waste of like $3,000 if I buy a $34,000 car. Okay? I'll buy a used car. Let somebody else take the hit on that $3,000 and then buy a used car that's 1 or 2 years old because that car will not lose $3,000 just like this one just did. All right, just what we wanted, more examples. Use the percent equation or the percent proportion, doesn't matter to me. I'll be using the percent proportion, but be careful. Make sure that you're making sure that you're putting things in the correct spots. So I am going to set up a proportion for this one. I am going to use my is over of idea. I am going to put 100 sitting here. But now, what? Why 30 on the bottom? I'm not saying you're wrong. Why did you want to put 30 on the bottom? It says of. 125% of 30 is what? So of 30, the 30 goes on the bottom, is what? So what will I put there? That's where the x goes. And then 125% goes in the percent spot. Okay? So now we're not talking about just what percent is this stuff. Now this stuff can be anywhere. So in this case, to solve this equation, I would do what? Multiply both sides by 30 to get x by itself. And I get x equals, yeah, 37.5. There you go. All right, so you got to think about where you're placing these numbers now. The next three problems are very similar. Just make sure you're placing things in the right spots. Go ahead. All right, as we work through these three problems, I want to ask a few questions. I want you to try to visualize what type of answer you're going to have, okay? So this first one, 125% of what number is 17.5? If I have more than 100% of something, will I wind up with something bigger or something smaller? I'll wind up with something bigger, okay? So if I have 125% of what number is 17.5, then that means I'm going to have some number, and then I'm going to multiply it by 125% to wind up with 17.5. So is this number that I'm going to find going to be bigger or smaller than 17.5? Smaller. 125% of a smaller thing will give me a bigger thing, right? So if I'm winding up with the 17.5, I must have started with something smaller. Set up the proportion. I have 100 sitting here. They give me the percent, so that must be 125 there. Then they say, is 17.5. So 17.5 goes there. And of what number? That's where my x goes. So because the variable's in the denominator here, I have to cross multiply. But look at how this is set up. I have 125, which is bigger than 100. So I have something bigger over something smaller. I must have something bigger over something smaller here also. Okay? So that number has to be smaller. I multiply and I get 125. X equals 1,750, right? Then I divide both sides by 125. And I get x equals what? 14. And I did get a smaller number. And I should have. 125% of 14 is 17.5. If I take 1.25 times 14, I get 17.5. 30% of what number is 12.5? So now I have 30% of something gives me 12.5. Is my something here going to be bigger or smaller than 12.5? This one is going to be bigger because I'm taking 30% of it and I'm winding up with 12.5. So that number must be larger. Thinking about that sort of thing can help you as you set these problems up. So I definitely have my 100 sitting here. They give me a percent, so I put the percent there. Now I just got to figure out which number goes where. So which one goes on top? The 12.5 goes on top. Because it says is. is 12.5. Is on top. Of what number? That means we have x on the bottom. Now think about this. 30 over 100. The 30 is smaller than the 100. The 12.5 must be smaller than that number, and that's kind of what we thought was going to happen. So this is set up correctly. Cross multiply and you get 30x equals 1,250. Divide both sides by 30. X equals 41.6 repeating. So 6, 7. Okay. And we did wind up with something bigger. Finally, 30% of 16 is what number? So if I'm taking 30% of a number, what do I wind up with? Something bigger or something smaller? If I'm taking 30% of something, I wind up with something smaller. So I better wind up with a smaller number in my answer. Set up the proportion. The 100 goes here. They gave me the percent, so that goes there. Now it says 30% of 16 is what number? So is, we don't know. Of, we do know. And take a look at this proportion now. 30 is smaller than 100. X is smaller, going to be smaller than 16. And we thought that that would be the case. So this is set up correctly. To solve this one, do we need to cross multiply? Multiply both sides by 16. 4 point what? 8. Exactly 4.8? So 4.8. It is exactly 4.8. So that's how you do this sort of problem. You guys are capable of doing 9 through 35 odd. Not capable of doing the entire section yet, so the homework won't be due tomorrow. But you need to get 9 through 35 done tonight. Make sure you're checking your work.